Hello all, and I hope everyone is having a good day. So let's continue with our gas laws, and our two major gas laws we've talked about. We have Boyle's law, which is where we have a constant temperature, and we get P1 V1 equals P2 V2, right? Pressure is inversely related to volume. And then we've also had Charles' law, we're at constant pressure, which is V1 over T1 equals V2 over T2. And we have temperature directly related to volume. Well, what happens if we don't have constant temperature or constant pressure? What happens if we have everything all together? Well, if volume is inversely related to temperature and if volume is directly related to temperature and inversely related to pressure, we can actually combine all these together. So our final, or a combination of these, is called the combined gas law. The only thing that's constant for the combined gas law is the moles of gas. And it's really easy. We're just literally combining these two together. We have P1 V1 over T1 equals P2 V2 over T2. That should be T2. And this is on the reference table. So our combined gas law puts both of these gas laws together, and it's the most common one. Right? Now, let's do some practice, because that's all there is to it. So let's say a ball is at, I don't know. Let's say a 2.2 liter ball is at 37 degrees Celsius and 100 kPa. What is the volume at 50 degrees Celsius and 150 kPa? And I like this question because what this is saying is that if we increase temperature and we increase pressure, what's going to happen to the volume? Why is that a good question? Well, if we think about it, if you increase temperature, volume should increase, right? And you increase pressure, volume should decrease. But the cool thing about the combined gas law is these are kind of two competing factors. And really what we're looking at here is we're seeing which one of these two numbers, the p-value or the t-value, is going to have the bigger effect. And it's cool both in a chemistry, science term and in a math term. We can think about it in terms of a science term to see which one is going to cause the volume to increase, change more, that temperature effect or that pressure effect. Mathematically, we can also think of it as which is going to change our V value more. The numerator getting smaller or the denominator getting smaller. Actually, both of them getting bigger. That one getting bigger or that one getting bigger, which is an increase more. So we can already start to take guesses before we even do things, but let's go ahead and do this. Hopefully you remembered. All gas laws must be in Kelvin. So let's convert that. 37 degrees Celsius. And we're going to convert that. Let's add 273 to that. And then 50 degrees Celsius plus 273 equals 323K. So let's go ahead and plug this in. We have P1 V1 equals P1 V1 T1. We'll say P1 is 100 kPa. V1 is that 2.2 liters. T1 is this 310K. P2, V2, T2. V2 we know is going to be our question mark or X. P2 is 150 kPa. T2 is 323K. So here we go. We have P1 V1 over T1 equals P2 V2 over T2. And then we're solving for V2. So V2 equals P1 V1 over T1 times T2 over P2. Easy peasy. V2 equals 100 kPa times 2.2 liters over 310K times 323K over 150 kPa. When we multiply that out, we get 1.53 liters. Cool, right? And so that is our combined gas law. Thank you so much for watching. Have a good day. Bye.